Okay, so remember last class we talked about two different forms of division. They were long division, and do you remember what that other one was called? Synthetic division. Okay, so we're going to be doing some more of that today, but really more kind of streamlined. So the lessons from last class and today really mesh well together. If you're doing your homework, they would be good assignments to kind of work at the same time or back to back. But today we're going to look at more specifically at zeros of polynomial functions. Okay, remember that zeros are the same thing as roots, so I'll use those words interchangeably. Okay, they mean the same thing, and also as long as we get real numbers, they're also x-intercept. So in other words, zeros and roots describe any and all types of values that make the equation zero. They're only x-intercepts if they're real numbers. So the only kind of numbers that aren't real are like imaginary answers. We can't graph, and they're not tangible, graphable values. So for the most part, we're going to see that most of the numbers we find as zeros are also x-intercepts, but not all. Okay, so we're going to be using something called the rational zero theorem next. So first I wanted to make sure that we know what a rational number is. It's basically a number that can be expressed as a fraction. Okay, so some examples of some things that are rational numbers. 1/2 is rational, but so is 2, because we could write 2 as 2 over 1. Okay, so it's whole numbers and fractions. Okay, what it is not is anything like the square root of 2 or 3i. Okay, anything where the number would not be able to be written as a fraction nicely. Yes?
Did you mean to write it as and as long as we real numbers?
No. Probably not. I meant to say as long as we have real numbers.
Okay.
So thank you. So as long as we have real numbers, they're also x-intercepts. Yes, that makes more sense, right? Okay, so here is the rational zero theorem, and what it's going to be is it's a way for us to kind of narrow down what types of rational zeros we might get in an equation that looks a little complicated to factor. Okay, so essentially it tells what rational zeros are possible so that you're not just shooting darts in the dark. But just know that not all of them are going to work. It's just which ones are going to be possible for the problem. So here are the possible rational zeros and what they might look like. So again, I'm going to emphasize that these are just possibles. Okay, it's always the factors of the constant, which is the number that doesn't have a variable in it, over the factors of the leading coefficient. Okay, so let's do one problem where we list the possibilities. And then we're going to kind of use this to our advantage moving forward. So list the possible rational zeros of the following function. 3x cubed minus 4x squared plus 12. So notice this cube thing is not something we know how to factor, right? We only know how to factor things that are squared. Generally, we use AC method for that, or quadratic formula when AC method doesn't work. So let's list the possibilities of things we want to try using our synthetic division process. So the possible rational zeros are going to be factors of 12, because that's the constant, over factors of the leading coefficient, which in this case is 3. So it's any factor of 12 is possible as the numerator, and any factor of 3 is possible as the denominator. So let's go ahead and just in list formation list out all the possibilities we could have. Okay, so if you want to go in some sort of order so you don't miss any. For instance, like 1 goes into 12, but so does -1. Like you have to include the plus and the minus version. What else goes into 12? 2, 3 goes into 12, 4, not 5, but 6, and then the last one's 12. Okay. By the way, notice that they like pair up, like 3 times 4 is 12, and then 2 times 6 is 12, and then 1 times 12 is 12. So if you kind of find 2 in the middle where they multiply to be that number, then you can kind of just know that you've listed them all, and you just need to pair them up with what you've already listed. What are the factors of 3? There aren't near as many. Just 1 and what? 3? Okay. So we're going to list all the combinations of the list on top versus the numbers that we said could have been the denominator. So here is all the combinations. Okay, first thing we have every one of the top numbers over 1. So notice I'm not going to list these in numeric order, but I'm listing all the same whole numbers. So it's like 1 over 1, 2 over 1, 3 over 1, so on and so forth. But we also could have all of those numbers on top over what denominator instead? We also could have like 1 over the 3, right? 2 over 3, and so on and so forth. So we have 1 over 3, we have 2 over 3. I don't need to list 3 over 3. How come? What is 3 over 3? 1, and I already listed that here, right? So I don't need to duplicate. But I've got 4 over 3. I don't need to list 6 over 3, right? Because that's what? 2, and then 12 over 3 is 4, so it looks like that's actually the end of my list. Okay, so all of these are possibilities for zeros. Okay, so notice this is 18 possibilities because each one of them has both a positive and a negative version. So that's still a lot of things to try, but it's not just random willy-nilly, let me just try every number I can possibly think of until I find the answers that work. Okay. Now, by the way, because of what we talked about last time, what is the most number of actual zeros we'll have? This is a cubic, so what's the most number of zeros we could possibly have? 3, right? So obviously not all of these are going to work, but it's a shortened list of what to try. Okay, it's still very long, admittedly, okay, but it's less than infinite number, okay, which is what we would have if we had no guidance whatsoever. So let's look at one where we kind of start from scratch. So let's say I wanted you to find all the zeros of f of x equals x cubed plus 7x squared plus 11x minus 3. All right, so before we start, let's talk about what we will have at most. Okay, there will be at most how many answers here? 3 zeros. So once we found 3, we don't have to keep trying to look at the possibilities. Once we found 3, we're good to go. So that we're not just randomly starting, we are going to use the rational zeros theorem to list all the possible rational zeros. And I chose this one because the list will be much shorter than it was on the previous example. Okay, so we're going to take factors of the last number over factors of the first number. Okay, so it's going to be a lot shorter list, right? So what are the factors of 3? 1 and 3. Make sure you include plus and minus, though. And then what are the factors of 1? Only 1, right? So my possibilities, then, if I list them out, my possibilities are either 1, -1, 3, or -3. Okay, those are my only possibilities of things that might be rational zeros for my equation x cubed plus 7x squared plus 11x minus 3. Okay, so how are we going to tell if these are 0? Well, we're going to use our synthetic division process from last time. So let's start with 1. Okay, so we're going to put 1 in the little box, and we're going to line up the coefficients of this equation, right? We have a 1, 7, an 11, and a -3. Okay, so this is why I said last time I want you to go home and practice synthetic division so that you're fairly quick with it. What should happen if it is a 0? What should we get in the remainder spot? We should get 0. So let's see if we do. Bring the 1 down, remember, and then multiply, add, right? So 1 times 1 is 1. Add those and you get 8. 8 times 1 is 8. Add those and you get 19. 19 times 1 is 19. So notice we don't really need to go much further here. Okay, the remainder is not 0. Okay, so what does that tell us about 1 then? It doesn't work, right? 1 is not a 0, so we move on. We don't spend time focusing on what it's not, we just move on to the next one. Okay, so let's test out and see if -1 works. So -1, and again, these numbers here are going to be the same. So bring down the 1. 1 times -1 is -1. Add those and you get 6. 6 times -1 is -6. Add those and you get 5. 5 times -1 is -5, and then if you add it, note that we don't get 0 again. Okay, so what does that tell us about -1 then? Not a 0. Okay, just to save time, I'm just going to tell you that 3 is not a 0 either. In other words, synthetic division doesn't give us 0 for a remainder. So you could you could check that, but I'm just going to kind of move this along quicker. So we've only got one more shot of nice rational zeros to try. What's our last shot of things we said might work? Our last shot is -3, right? So let's see if that works. So we'll bring down the 1. 1 times -3 is -3. If we add that, we get 4. 4 times the -3 is -12. Add that up and we get -1, so it looks promising, right? -1 times -3 is 3. And finally, we got what we were looking for, which was what? We got a remainder equal to 0. Okay, so what it tells us is 3 is a root or a 0. But remember, how many were we expecting to get? We were expecting to get 3, right? But we've listed through all of our 4 choices and we only found 1 that worked, okay? But the point is, now we actually have something left over here, okay? So how could I write what my result is when I divide? So this is my c, my x squared, right? So this stands for x squared plus 4x minus 1. So this is what I have so far, and then let's talk about what I might still be able to do, okay? F of x was x cubed plus 7x squared plus 11x minus 3. Okay, I was dividing by x plus 3. By the way, why did I say it was x plus 3? Do you remember what we did last time to the sign when we went to synthetic division? We changed the sign, right? So it actually was an x plus 3. And we got, as a result, x squared plus 4x minus 1. That's what we got. Okay. But note that there are actually 2 more roots here. There are 2 more zeros here. It's just they're not necessarily going to be pleasant ones. They're not rational zeros. Okay. So to find the other 2 roots, we're going to factor or use quadratic formula. So I just want you to know that this is actually one that we've already done last time. You just probably forgot. Okay, so if you see example 8 from section 3.3, it actually has this already quadratic formulaed out. Okay, and so what you end up getting is from this example, you get x equals -2 plus or minus the square root of 5. Okay, so 3.3 notes, if you were to flip back, you would see that we got that. So in other words, the three roots then are -3, -2 plus square root of 5, and also -2 what? Minus square root of 5. Okay, so there are three answers, but just to let you know, this one is rational, and these two are not rational. Okay, so I like to think of rational zeros as the nice ones. So we use the nice roots, and then we get it down to a squared equation so we can use quadratic formula to find the not so nice roots. Okay. All right, by the way, we could graph all of these, right? But which one would be easiest to graph clearly? -3 is easiest to graph, right? But we could use our calculator and figure out decimal approximations of those and graph them as well. Okay, so that's kind of what we're going to be doing today. We're kind of going to just be kind of fact-finding and figuring out which zeros should we try out based on the rational zeros theorem, and then we're trying to get down to a squared result so that we can factor/use quadratic formula. That is your number one goal, just like I said at the last part of class last time. We want to get it down to squared so that we can handle it easier. We are most comfortable with squared equations, not with cubes and fourth power and fifth power. We're not super comfortable with those. Okay? All right, so before we begin, okay, there will be at most how many? Yes, there will be at most 4 roots / zeros. Okay, that's because this time it's a what power equation? Fourth power. Okay, so first we're going to list all the possibles. Okay, remember this only gives us the possibilities for the rational zeros. It doesn't give us the possibilities for the ones that aren't so nice. Okay, but if I want to list them all, it would be factors of the last number this time, which is 4. Over factors of the first number, which in this case is 1. So what are the things that go into 4? 1, 2, and 4, right? And that's over any factors of 1, but notice that's just 1. So let's list what the possibilities are, right? What are my possibilities then? In other words, you want every number on top over every number on bottom, right? Notice the bottom's not really doing anything to our numbers though, right? When you put something over 1, it just stays. So our possibilities are 1, -1, 2, -2, 4, and what other one? -4, right? It's all of these numbers over all of those numbers. Okay, so we're going to cheat a little bit. So we could do synthetic division 6 times, or at least maybe 6 times until we find one that works, right? Or we can kind of use our calculator since we have one, since I'm going to let you use one on your test. Let's look on the calculator to see which zeros might be best to try first. In other words, instead of spinning our wheels and trying them all, let's just like cheat a little bit and see which ones we think we should focus on first. Okay. So if you have a calculator, you can punch this in with me. If not, you can just kind of look up here. Let me see if I can get it out of the glare. So we'd go to our y equals and we'd enter in x to the 4th minus 2x cubed. Remember that if you don't have a graphing calculator at home, you can use some online free graphing calculator programs. Desmos is one of those, but there are others too. Okay, so what are we looking for, by the way? What's another name for zeros? There's roots, but what's another name for it? X-intercepts, right? So we want to find out, where does the graph look like it's crossing the x-axis? Okay, so I'm zoomed in weird, so as soon as it graphs, I'll adjust it. I had zoomed in one of my previous graphs. So let's take it back to the normal window. There we go. So I'm trying to see where I think it crosses. Okay. So it's hard to see if you're in the back, right? But you might have to watch the video back later and zoom in. I think it looks like -2. It looks like in between 0 and -1, so I'm not going to mess with that one, right? That one looks uglier, okay? And then it looks to me like maybe also +2, okay? And then maybe something in between 2 and 3. So by the way, how many answers are we going to have just by looking at this? How many times does it cross? 1, 2, 3, 4, right? We just want to pick the nice ones first, right? We want to make it easy on ourselves, okay? So when you look at the calculator, it looks like -2 and 2 might be good. Okay, so that's where we're going to start. Rather than spinning our wheels and trying all 6 of these, we're going to hone in on the ones we really feel like are going to work. So it doesn't matter which one you try first, so let's try -2 first. So we line up the numbers from the original problem. Make sure if you're skipping one, what do you put in its place? 0. So bring down the 1. 1 times -2 is -2. -4. -4 times -2 is 8. Add those and you get 3. 3 times -2 is -6. Add those and you get 2. And then 2 times -2 is -4. So we have some success here, right? Notice that the remainder is 0. Okay, so what does that tell us? So -2 is a 0. Well, when we write it out, it'll be x plus 2, if that's what you're asking. Yeah. Okay. All right, so now we're going to try the next one that we were pretty sure would work. Okay. But here is the trick. You actually want to use the reduced list. And I'll show you what I mean by that in a minute. In other words, don't go back to the original. We have now a reduced equation here because we already divided it out and made it a little bit smaller. So notice if you count up, this is x cubed minus 4x squared plus 3x plus 2. So we don't want to go back to the 4th power when we can go to something cubed and it's a little bit easier. Okay, so we're going to try 2, but we're going to use this reduced list instead. So 1, -4, 3, and 2. So we're going to bring down the 1. Okay, 1 times 2 is 2. Add down the column and you get -2. -2 times 2 is what? -4. Add down that column and you get -1. -1 times -2 is 0. So we have success again, right? If we get a remainder equal to 0, what does that mean about +2 also? It is a 0. But do you see what we're doing slowly as we go? We started off with a 4th power, right? Then we reduced it to a what? 3rd power, okay? And then what about this? What do you notice this is? This is the 2nd power. So do you see what I mean by we're slowly whittling it down power by power? Every time we find a root, we're reducing it by 1, okay? Okay, so far this is what we have. So we have that f of x, which was x to the 4th minus 2x cubed minus 5x squared plus 8x plus 4. That was our original equation. Okay. Now we do need to remember to change the signs, right? So what kind of parenthesis thing do I get for -2? I get x plus 2, right? And then what about here? I get x minus 2, and then I get the result that I got, which was x squared minus 2x minus 1. Okay, so here, if you really want to label, here is where we showed x is -2. Here's where we showed x is 2. But notice we still have 2 more zeros here. Okay, we just need to do what to find them? We either factor or we do what? Quadratic formula, always. Okay, so we're going to find the 2 more roots. Okay, this does not factor. So x squared minus 2x minus 1 does not factor. It's close, but it doesn't work. So since it doesn't factor, we will use what? Quadratic formula. So we get x equals -b, right? So since b is negative, it's positive 2. Plus or minus the square root of b squared minus 4ac all over 2a. So really watch your signs here. That's probably the number one mistake. So we end up getting 4 plus another 4. So we get 2 plus or minus the square root of 8 over 2. Okay, you cannot cancel the 2's out right now because we'd have to be able to cancel a 2 out here as well. But we can simplify this. Okay, and so if you work this out, I'm not going to do it off to the side, but this does work out to be 2 square root of 2. So think of it this way. You could break 8 into 4 times 2, and the square root of 4 is what for sure? It is 2, right? So you take the square root of 4 and you leave the square root of 2 alone. So now you're allowed to go ahead and divide out by a 2, but just know that when you do that, you're dividing 2 by itself, so actually you get a bunch of 1s. So I actually get 2 more answers which look like this. So the 4 total roots then, the 4 total zeros were -2, 2, 1 plus square root of 2, and 1 minus square root of 2. Okay? Notice these are rational, and these are not. So what's kind of our process? We don't start with the ugly, non-rational things. We start with the what? We start with the pleasant things that we think we can find, right? And then we move on finally to the ones that are a little uglier. Okay? So by the way, these are still graphable. They're just decimals. Remember how I said that 2 of them looked like they were crossing in between? So let's look back at that graph. Maybe. Okay, so let's look back and kind of confirm, right? It looks like -2's here, right? This one is the 1 minus square root of 2. Like if you were to punch that in your calculator, you would get negative point something. Okay, here's the 2, right? And then here is the 1 plus square root of 2, which is like 2 point something. So what you try to do is you try to find the things that look nice, okay? And then you work from those, and then you worry about the more difficult ones at the end. So these are all going to be different on your homework. So hopefully you kind of see our strategy. So what is kind of our general strategy? If we start off with big powers, we just start slowly hacking away at it, right? What are we trying to get down to so that we can move forward? A squared, and then we can factor / quadratic formula. Okay, that's going to be your overall goal. So let's say I gave you this one. So find the zeros of g of x equals that whole thing, right? And then factor g of x.
Is that a squared or is that a cube?
It's a squared. So x to the 4th minus 6x squared. Okay, so first let's list the possible rational zeros, and I think you're going to see why we probably want a calculator at our disposal. The possible rational zeros are going to be the factors of 24 over the factors of 1. The problem with that is there's a lot of factors of 24. Okay, so let's just start listing them. 1 and negative 1 are factors. So are 2 and negative 2, 3, 4, 6, 8, 12, and 24. Notice I'm putting all of those over 1. Okay, but that's still an awful lot of synthetic division I'd have to do, right? Notice that there are, I'm not going to list them out this time, but there are 8 possibilities. Actually, double that. Why is it double? Yeah, positive and negative. So there's 16 possibilities. So can we agree that it's helpful if we have a little help from our calculator, right? I don't want to try out 16 things and trial and error it until I finally find one that works. Okay, so I am going to look at the calculator for a hint on where to start. Okay, so if you don't have a calculator at home, it's not that you can't do these problems, it's just you're going to have a lot more trial and error, unfortunately, than you probably really want. Okay, so let's look at what the graph of this looks like. I don't know why I can't find something that's not glary. All right, so x to the 4th minus 6x squared minus 8x plus 24. Okay, and remember, what are we looking for?
Oh, we're across.
Where it crosses. Okay, so this graph's a little different. So what do you notice about it? It only looks like it hits one time, right? So maybe we'll zoom out and see if we can get something a little bit more, okay? But notice, even if you zoom out, how many times does it look like it hits? Only once, unfortunately. Okay, so let's go back. Zooming didn't really help me. Okay, so it actually looks like x equals 2 is the only nice root. Okay, so we're going to talk about more about that graph, so I'm going to put that off to the side. But let's try the one that we feel like will work. Okay, so be careful though. Why do I say to be careful? What do you notice about the equation? We're missing third power, right? So we need to put a what in that spot? A 0. If you don't put a 0 in the spot, it's not going to come out to be the remainder of 0 like you expected. Okay, so we bring the first number down. 1 times 2 is 2. Add up the column, we get 2. 2 times 2 is 4. Add down the column, you get negative 2. Negative 2 times 2 is negative 4. So you get negative 12. And then last but not least, negative 12 times 2 is negative 24. So we have success, right? Why do I say we have success? The remainder is 0. Okay, so that tells us that what? 2 is a 0. Okay, so let's talk about what we have it reduced to now. This is x cubed plus 2x squared minus 2x minus 12. Okay, the problem is that I'm not ready to go to factor yet. Why am I not ready for that? Because it's still x cubed, right? And I really need it to be what so that I can factor it? X squared. Okay, so here's where what we did about a week ago really comes into play. Okay, notice that, so let's go back to the graph. Notice that not only does it hit at 2, do you notice what else it does? That's maybe different than the previous graph. It actually turns at 2, right? And we have something we know about graphs that turn. Okay, we just might have forgotten it. So let's talk about that. Okay, so the graph turns at x equals 2, which means that its multiplicity is even. Remember, multiplicity is how many times something happens. So the fact that we know that it turns is actually what we need to be able to do this problem, right? Which means the multiplicity is at least what? What's the smallest even number we have? 2, right? So basically we're going to try x equals 2 again. And we're going to try it again because we're pretty sure the multiplicity is 2. But we're not going to try it on the original list. That would be goofy, right? We already did that. We're going to try it on the reduced list. Okay, so here's the reduced list. 1, 2, negative 2, negative 12. So we're going to bring down the 1. And then let's see if this works again. 1 times 2 is 2. Add them up and you get 4. 4 times 2 is 8. Add those up and you get 6. And then 6 times 2 is 12 and we get 0. Okay, so we've got some success, right? Because we got a remainder of 0. So basically 2 is a 0 again. All right, so now notice we are down to x squared. So this is x squared plus 4x plus 6. Okay, so this is what we've got, right? So let's go back and see if we can fully factor the original, right? It was x to the 4th minus 6x squared minus 8x plus 24 that we started with. Okay, and we found 2 zeros. They just happen to be what to each other? The same, right? So this is x minus 2, and so is this. So for both of these, note that we get x equals 2. Okay, that's why you change the sign, by the way, because we care about what makes the parentheses 0. And then when we did that, we got an answer of this, x squared plus 4x plus 6. But just know that there are 2 more answers here. So I'm going to circle this because one of the things I asked you to do was fully factor the original, okay, which that's as far as we can go because this does not factor. Okay, so I'm just going to say since x squared plus 4x plus 6 can't factor, we will use what again? Quadratic formula. So this is why that first week I try to review you on quadratic formula because you're just kind of expected to know how to use it here. Okay, so let's see if we can find the final 2 zeros and then we'll talk about why we get the answer we do. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So I get negative 4 plus or minus 16 minus 24. So maybe you already notice what might be a little problem. So this is the square root of negative 8 over 2. In other words, what kind of answers is this? We're going to get what kind of answers when we try to take square roots of negatives? We're going to get imaginary, right? So let's just work on what this would be. So I don't want to spend too much time on this, but just remember we kind of already did this one. Square root of 8, do you remember what that was in the previous one? It was 2 square root of 2. Okay, so it's just going to be 2i square root of 2. In other words, do the square root like you normally would and just stick an I in there. That's how you deal with imaginary answers. And then kind of like the last one, we can cancel a 2 out of all 3 parts. Remember that you never, ever, ever cancel any number out of under the square root. You can't do that. Okay, so we end up with negative 2 plus or minus I square root of 2. Very strange answer, right? So what are my zeros then? I actually only have 3 zeros. How come I only have 3 though?
-3 got 2 twice.
Got 2 twice, right? So let's write that. So we got 2, and it had a multiplicity of 2, right? So it kind of repeated itself. And then we have -2 plus I squared of 2, and we have -2 minus I squared of 2. Okay. Note that these are imaginary, right? So they are not graphable. So we're going to look back at the graph and kind of note that we actually kind of already knew that anyway. They're not graphable, okay? So they are zeros / roots, but they are not x-intercepts. You cannot graph things that are imaginary. So here was all of the zeros. Do you kind of see that we still had 4 things taken care of though, because the 2 repeated itself, right? So how come I kind of already knew I was going to get some imaginary answers? So let's look back at the graph. Okay, what do you notice about the graph? Most fourth power would hit the x-axis more than this one did, right? And this one did not hit the x-axis as many times as we thought, and why didn't it? Because 2 of the zeros were what kind of answers? Imaginary. That's why it didn't work. Okay, that's why it didn't necessarily work like that. Okay, so I want to give you a couple of problems that will be more like what I'd probably ask on test 2, so that you can kind of gauge and see what that's going to look like, so that you're not thrown off by that. So, let me make sure I can actually do it here. All right, I had to pick a problem that would work well. All right, so if I tell you that x equals -2 is a 0 of the following function. Just kidding, make this a 7. Let's say 7x squared plus 13x plus 10. All right, just kidding. Let's make this a 6. I'm trying to make it nice. If I just make up numbers, it's not going to be nice. Okay, so if you already know that is an answer, I want you to find the other roots or the other zeros. And I want you to fully factor g of x. So this is probably more like what I might ask on test 2, because we don't have a whole lot of time for you to do a whole lot of trial and error, like does this work, does this work, is this going to work, okay? So I'm going to probably start you off with what we already know works, and then we'll kind of go from there, okay? So we know that -2 is going to work, but that's not really the only point. We still have to figure out what we get as a result when we divide by x plus 2. Or a root of -2. So bring down the 1, right? 1 times -2 is -2. Here we get a 5. 5 times -2 is -10. Add that down. And then notice we get 0. Okay? So no shocker there, right? The remainder is 0. So what does that tell us, just like I told you originally? Yeah, this is a 0. Okay, so you might think, well, why did we do that? Well, the reason we did that is because we needed to get down to a reduced equation, right? We started with a cubic, which we're not really sure what to do with. What do we end up with? X squared plus 5x plus 3. Okay, so by the way, we're ready to go ahead and say what it factors into. So here's what we started with, x cubed plus 7x squared plus 13x plus 6. And that's going to equal what? What do I get for a negative 2 root? Yeah, x plus 2, and then I get x squared plus 5x plus 3. Okay, so this stands for the root x equals negative 2, but we're not finished yet because there's 2 more zeros here. Okay, it's just that I'm going to circle this because that's one of the things I asked you to do, right? So we try to further factor the second part, but notice that it won't, right? How can you quickly tell this isn't going to factor? No factors of 3 add up to 5, right? The only factors of 3 are 3 and 1. It's not going to work. Okay, so what do? Quadratic formula, right? So we say, okay, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I end up getting negative 5 plus or minus the square root of 25 minus 12 over 2. So notice this one doesn't really reduce much. I just get that, and there's nothing I can really do with 13 because it's prime. But I actually have my 3 zeros now. Okay, what was my first nice zero that I told you about originally? Negative 2, okay, and we use that to find the final 2, which was negative 5 plus square root of 13 over 2, and also what else? Minus square root of 13 over 2. Okay, and that's it, right? Could you graph these if you wanted to? Yes, but which one's definitely easier to graph? Negative 2 is definitely easier to graph, right? So we start with the easy peasy ones, and we move on to the ones that are more difficult when we get down to a squared equation. Okay, so see how kind of quick that is? It doesn't really require a whole lot of work. So let me give you one to try. So give me a minute because, again, I got to make sure it works nice. Okay, so I want you to try this one on your own. I'm going to give you a few minutes. So, let's say that I tell you that x equals 4 is a zero of the following function. X cubed minus 3x squared minus 6x plus 8. And I want you to find the other zeros and factor it. F of x, I mean. So if you're watching the video back again, pause it while you'll work on this. Well, when you drop down the first number, you just drop it down as it is, and then you multiply, put it in the next column, add. Yeah, multiply, add, that's what you do over and over. I mean, you can have out a calculator if you want on these two. All right, so let's take one more minute and see how far you can get in that 1 minute. All right, so y'all tell me how, where we start here.